Dad!
I knew I should have locked that door. Welcome back. The first thing I want to do is apologize, okay? Mom always said, don't ever apologize right out of the gate because it's going to put people off. But I have to apologize. I'm sorry it's taken so long for us to drop our next episode. But I got to tell you, it came out of 26 man-hours of work, and all of which is captured in raw video, and it has to be edited. So this is going to turn into a series. We're going to break this down into parts for you, okay? We're going to cover the mechanical stuff. We're going to cover the electronics. We're going to cover recapping. We're going to explain how the tubes work and what they're expected of them. So in order to accomplish that, we've got to break this up into a series, all right? I want to be able to show you different aspects of things to look for, okay? Things that I'm looking for. And for you DIYers, I'm hoping that it's going to basically bring to the fore techniques that you'll be able to use if you're going to be working on your own stuff, okay? And in order to accomplish that, let's go back to the lab.
So, I found something that you might be interested in.
Oh, great. What, another lost puppy?
Yep. Here's good. Sit this all aside real quick.
Sure, no problem. Just what I've always wanted, a cardboard box.
Yep, and I have two of them.
What do we got? Holy sh...
Yes, so... Quick 101 on Griffin.
Yeah?
This is before the name Denon came to America.
That's why it looks like a Denon.
And,
so this is hopelessly tubes.
You're getting ahead of the game, but you're correct.
Porn!
Well, you're gonna be disappointed actually. This doesn't have a schematic.
Oh, well. No, why make it easy?
Right.
4-track stereophonic 1962.
Mm-hmm. You got a piece of wood by chance somewhere?
Oh, it's a rather personal question.
Well, I don't want to care about that one. There, that right there, yeah. And just leave it there so I can get you the next thing.
Some assembly required.
Mm-hmm.
Wow, this is in super condition, man.
Mm-hmm. I was really happy to find this one.
So which one is this? Because there's two different types of models. There's a 707A and a 707B, which is a 3-speed.
Yeah. This one is a 707A, 4-track, 2-channel, 2-speed machine.
So 2 speeds being probably 7.5 and 3 3/4.
So there's a sleeve on the capstan that you actually have to twist off and then pop that off, and then there you get your 3 3/4.
Okay, is there a place to store that so it doesn't get lost?
I didn't find one.
Uh-oh.
So you're kind of on your own on that one. This doesn't even have lifters whenever you fast forward and rewind.
Yeah.
Pull the tape down.
Right.
You actually have to manually bring down the cover in order for you to actually take the tape off the heads when you shuttle fast forward and rewind. So that's how primitive this is.
But I can't get over the condition this thing is in. Because, I mean, this thing is, well, 62, so 62 and 40 to 2002 is 40 plus 23. 63, 62 years old?
Yes.
Did I do the math right?
So from 1962, and it's 62 years old.
Okay. And 2 times 2 is 4.
4.
And it's 2024.
Mm-hmm.
Okay.
Yeah.
Okay, so we have synchronous motors here.
You have 3, and it's a solenoid driven. The power comes from the RP unit, so there's actually a Cinch-Jones connector back there that runs the RP power and functions.
Right back there.
Mm-hmm. And so...
Hang on. Are you sure this is a match set?
It came this way.
Are there instructions?
I mean...
Tab A into slot B.
Is it really that easy?
No.
But check this out.
Yeah.
So you see this transport.
Yeah.
I can already tell you that that's a different picture of an RP unit.
Yeah, because the switches are on in different places.
Switches are in different places.
But this is a 725. What model RP unit is this?
I don't know.
All right, well, these are at least labeled to Mecha, which means we have to point this that way. So this one's going to fit there. And this one is going to fit there. So this is the record head. But
Oh, geez.
that's a 6-pin Cinch Jones connector, and it's a 4-pin on this unit.
Okay, I'll admit that I did not see that at first.
It's not a deal breaker.
Yeah,
It is not a deal breaker.
Well, can you still get Cinch Jones connectors or something?
Oh yeah, absolutely. I don't want to set this on the knobs or on the meter faces, so I'm just going to set this down here. I mean, what's the backstory on this?
So, there's actually a thread on the internet about this very machine on Tapeheads, the website
Okay.
Tapeheads,
Okay.
about the Griffin 707A. And the gentleman that actually owned that machine that made the thread decided to sell it. And so I reached out and asked him if he was willing to sell it because there's not a lot of information on this machine at all. The only thing I can tell you is that the name Griffin came because they were trying to appeal to the American market, and instead of going with a name like Denon, just like Akai and Roberts.
I was
did.
going to say.
Yeah. So here's something you need to notice. I'm gonna grab this camera right here. This
I could if you held the camera still.
Well, thanks. I say the same thing about you. But this is a 100-volt AC motor.
Okay.
And that's what gives me the assumption that this is actually a
Japanese machine,
foreign unit, yeah.
because it's operating on 100 volts.
That's what the motors are asking for. But yes.
Okay, but that's a supply motor. Does the take-up motor have the same markings on it?
As a matter of fact, it does.
Really?
Yeah.
It's got 3 motors. What's a capstan motor say? I'm not sold.
All right. Well, I'm gonna put this on its side.
Wait a minute. Stay there. Look.
Yeah.
Okay. Right there. 1,800 RPMs, 60 cycles. So we know it's America.
Okay.
117 volts.
So why is it that the take-up and supply motors are 1 voltage and the capsule
Because
is not?
typically they're not going to really have to run at full voltage. The only time they're going to get full voltage is when they're fast forwarding or rewinding, when they're in shuttle mode. Now, as far as torque is concerned, all 3 of these motors are going to have hysteresis capacitors on them for torque reasons. But we want to make sure we get the voltage right. In fact, I'm looking right up here. I'm looking at this resistor, and that's a heavy duty. It's a 5-watt wire wound. Okay. That may very well be the dropping resistor for those motors.
I'm gonna set this aside, but we'll take a look at the RP unit and see what that looks like.
It looks like an RP unit.
I'm glad you think so.
First thing we do is we take a Post-it so they don't get lost. And that's crinkle paint. Wow.
I'll take that for you.
Okay. Needs to be cleaned up a little bit, but 60 years old?
62 years old.
Because that makes all the difference. We've got AX7, 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 AU7. AU7 is going to be a medium amplification factor, whereas the AX7s are going to be a high amplification factor, what they call high mu,
Okay.
MU. Okay, so the AX7s are going to be providing a tremendous amount of gain, and then the AU7 is probably just going to be sort of a buffer stage going into the finals. So we've got another 12 AU7 down here, and with this can here, I'll bet you that's a transformer. This has got to be the bias oscillator.
Okay, for recording?
Yeah.
Okay. 6x6?
6x4, I think.
6x4.
6x4, yeah. Full wave rectifier. And then these cans here, of course, are all those filter capacitors, and these are all duals. Okay, there's 40 and 40, 20 and 20, 20 and 20, 20 and 20. I think I've seen everything I need to see on this side.
So, do you feel like you want to use the Variac, or?
Absolutely.
Okay.
I would not, I'm not going to diddle with this without having some kind of protection.
Because they're tubes, right?
Because they're tubes, mostly because it's old.
So we're gonna put this right here. I guess do the only 2 out of 3 Cinch Joneses that we can do.
This is the record head and the erase head, I'm sure.
Yeah. Yeah, I don't think you want to put the erase head on the 4 pins it takes to run the playback heads.
No, because it's probably got close to 80 volts coming out of that. So what do we want to do? You want to basically put some juice to it?
Put some juice to it on the variac
And look for smoke?
And look for smoke, yeah. So
before we can actually fire this thing up and leave it running long enough to actually do some checking of the RP unit and so forth, I want to go ahead and just oil up the motors. The filler tubes on this motor are facing up, so I'm going to go ahead and do this one while it's here, but I'm going to need it closer.
okay. Yeah, because I see the filler tubes are on the very bottom of the capstan.
I'm not going to actually dribble that into the tube. I want to use my eyedropper.
Oh, okay. I never thought to use an eyedropper.
Now, we're not going to lubricate these with the motors running. We will spin them manually at first, just to get the oil around inside there. I know it was probably lubricated at the factory. I'm going to assume that those motor shafts are dry. What I'm going to do is I'm going to just insert this into this tube here. I'm going to blow some bubbles, and then I'm going to draw the oil into the eyedropper. And I'll probably put half of this in the front and the other half in back. Okay, it just fits right in there. So I'm just going to gently squeeze the bulb, and it stops. That means the tube is probably full. Now, I don't know if we can get to the solenoid on that. Let me see. I think this is it here. Okay. Just give it some really good spins, maybe for about 10 or 15 seconds. Have you noticed any difference?
Not immediately, but I mean, I feel better about spinning it.
And this is just going to soak into that, kind of like a sponge. It's just felt. I'm going to do the other side now. Gravity is actually going to feed this, and that's plenty. I don't know about you, but that looks like it's better. Okay, I think that's got it.
Do you notice the name Denon on the motor heads?
Yes, it's like, okay, secret is revealed. This has actually got a date stamped on there, 1962. But it was probably released in 1963, but I mean, parts are manufactured in 62.
That's really what matters.
Again, I just want to be able to fire this up and leave it running so that I can be working on the RP unit and actually determine what, if anything, needs to be addressed in the RP unit. Clearly, there's no load on there right now, so I'm just going to back this all back down.
Okay.
Give me the power.
Oh, I'm feeling vibrations. Well, I'm
Gotta keep those love good.
These things so good, we're going to get copyright struck. Probably the capstan motor.
So yeah, it wants to run. I'm not seeing anything else going wrong.
Okay. Yeah.
Not yet, but I'm only at like 25 volts.
Yeah, you can see.
There's 30.
All right, the fan is slowly spinning on the capstan, so this is probably like an always-on motor.
Okay, but I'm not seeing any excessive load. So I'm at 60 volt. Fan is taking off. You can see the capstan flywheel is spinning. I'm at 90 volts. Okay, I'm going to stop at 100 because we still have a mystery as to whether or not this is operating at 100 volts or 117. I'm kind of the opinion that it's 117. Brakes seem to be in pretty good operational condition because when you spin it in the direction that it's supposed to be going, but then you try to turn it in the opposite direction, there's more friction, which is typical. And if the brakes are really that tight, I don't think I'm going to be using any 1mm tape on this.
I wouldn't expect that at all.
Okay. First of all, it's fired up. I don't have any smoke coming out of anything. Okay. There is a little unspoken of. See, that tube is basically room temperature. Okay. This one's a little warmer, but not hot.
So why are you checking temperatures? What's the significance of this?
Well, because in something this old, capacitors tend to get leaky. And when there are capacitors that are used to couple one stage to the next in the amplification process, you go from one tube to the next tube to the next tube, and you're going to have capacitors to do that. Older capacitors get leaky. Now, they're supposed to block the DC high voltage coming off of one tube going to the next. And when they get leaky, they don't block the DC like they're supposed to. And what they do is they end up over biasing the next stage of amplification, and consequently, because that tube is over conducting, it gets real warm, and it gets warmer than it should have. These tubes, except for the AUs, are virtually cold. Oh, you had it powered off.
Yeah, I just turned it off because we didn't lubricate
all
the
right.
motors.
So it's colder than it was. So rule number 1 in engineering and troubleshooting, you ask yourself, what's changed? Okay, and that will lead you to the solution. So, so this thing is not fired up. Power light's not on.
One thing that I mentioned at the early part of the video was it has manual tape lifters.
Yes.
So the way you do that is you do this.
Okay, so these things actually move into position when you open the door.
Right. So right here are the lifters for the tape heads. Because if you had the machine like in operation when you're shuttling tape, it'll actually be playing back the audio.
Yeah, and of course at high speed it's going to really wear the heads down. Mm-hmm. But what I'm also noticing is that this thing looks to be cracked. Okay. And how on earth would that happen?
Is there something that's supposed to like go in that little like semicircle there? Okay, wait, you know what that looks like? Hang on a minute. So the guy that I bought it from left me a little Ziploc bag.
Yeah.
And he said, I found the crystal rod in the box. It may be part of the transport, not sure. Is that what he's talking
about?
Wait
a minute, okay, this little gizmo here is gonna go in that little groove there. That way the tape comes in contact with this instead of this metal piece. And I do think that that's metal, but it's what we used to call Japanesium. It's like pot steel. It's very low grade steel, and that may be why this is cracked.
Okay.
But now this tape lifter is actually mounted to this door.
Yes.
So they're actually moving out of the way when you basically load the tape in here into the tape path, and then you close this door. A couple of things happen. Okay. First of all, the lifters move out of the way, but then these little covers actually create a seal, sort of a magnetic seal around the heads in order to reduce stray signals, noise, RF, and things like that. I'm concerned that there's only one crystal here. This is clearly going to need 2.
Gives us a chance to look at the heads anyway.
They don't look worn. Oh, but there's absolutely no catch on there. Fingernail test. You can't feel a lip on there that's been worn by tape passing over the head. You're never going to start to feel a groove like that until you get past about 80 to 100 hours of actual runtime. So this has got to be less than 80 hours. I think it's probably closer to 15. This is in really good shape. Erase head, record head, and the play head.
Here's something that might be interesting that I've recognized about the RP unit.
Okay.
It doesn't say left and right whenever you're choosing what input to record.
Yeah.
It says...
You know why?
Why?
Well, because they hadn't really decided which was left and which was right. How about that? Okay. But looking at this, what do you see?
Up and down.
I see an upper channel and a lower channel. Oh. This is going to be a cakewalk to work on. Famous last words.
Oil caps.
Yeah, that's probably something we want to be careful about. Oil capacitors from this vintage, the oil in them could very well contain PCBs, which is a carcinogen. I know when I worked on a number of vintage broadcast transmitters, that the capacitors, of course, extremely high voltage, they would be oil filled.
So right away, I see a problem.
Which, more than just one?
Right here.
Oh, that.
Do you see what's wrong with that?
Well, not just by looking at it, except that it's slightly discolored.
Yeah.
But it's coming pretty much raw off of that high voltage to that resistor, and it's been hot.
Yeah.
So the question is why? Whatever's going through that resistor, current times voltage equals wattage. And the thing is, after 60 years, I might expect that to be discolored, but there's no evidence on this unit that it's been operating for thousands of hours that it would have done that over time. So I have to be concerned that something has happened recently that would have contributed to that. Okay, I'm at 60 volts. Okay, the motor's starting to turn. 100 volts. All right.
Tubes are biasing. VU meters are changing. I thought the left channel was a little bit louder than the right channel.
Well, it wouldn't have been loud exactly, because it's just basically the DC voltage between stages wherever these VU meters are tapping the signal from. There was just a DC differential that basically the meter interpreted as a signal. And I mean, most tube equipment will behave like that, okay, because as the filaments warm up the tubes, they begin to conduct, but the next stage may not be actually getting that signal yet, so because they're still warming up. So what happens is that you get a different DC differential going. The playback volume control, wow. Oh, okay. Well, I can tell you what that typically means. That meter is going to be probably after the second stage. Let's see.
Wait a minute.
Pots do get scratchy and they crackle and so forth like that, but you hear that in the signal. The fact is, though, this thing is pretty, I mean, it's been powered up for now almost a minute, okay? Yeah, it's still doing that. So there's something going on there where the signal that is going through this pot onto the next stage has got a DC differential on it, and the pot is simply wiping between the two, and it's registering as an actual signal. That doesn't have to be, just because the needles are dancing a lot, doesn't necessarily mean that the signal is really, really strong. It's just that it's enough in the milliamp or microamp range to actually be displayed on the VU meter. You know, I'm looking at these capacitors. Okay, now this all looks to be original. I don't really see this as having been worked on. I mean, even this little cable bundle here that's tied up. I think what I'd like to do is to just check some voltages. Okay, I mean, you know, you've got me thinking now that, you know, there might have been a signal on there, but I mean, if, for example, if there was some kind of bad filtering going on and there was some hum involved, then it should show up on the meters, or at least be detectable.
But wait, there's more.
What he said. Listen, the next episode, we're going to get investigative. We're going to get into this thing and figure out some of the voltages, figure out just how bad off this thing really is. Okay, so we've already done that preliminary stuff, you know, evaluation, but we're going to actually get into the weeds on this next thing. If you've liked what you've seen, give us a thumbs up. I'd appreciate it. If you've got some comments, positive, negative, that's cool too, because I want to hear from you. I want to see what you're thinking, okay? Because this is all for you guys. And subscribe to the channel so that you get some alerts, you know, when we drop the next episode, so long as it doesn't take us 6 weeks like the last time, all right? And then there's this thing called Patreon, okay? We've got a Patreon account, and if you pledge to the Patreon account, then you're going to have access to things like merchandise, okay? We're actually going to get some Oxford shirts with the 6R logo. That'll be kind of cool. And also the service manuals. When we've got service manuals for an item, and I've got a ton, well, those are going to be uploaded. You'll have access to those as a Patreon subscriber. So I want to thank you for watching. Stay tuned for the next episode.